Okay, so we talked about kinetic energy, and we said kinetic energy was when an object possesses this energy as a result of being in motion. So it has some kind of a velocity, and what we said was that let me see if I can find out where we're at here. Here we go. Kinetic energy. Kinetic energy is 1/2 mass velocity squared. So if it's moving, it has energy because it has mass and it has velocity. And we calculated that in units of joules. So energy is this ability to do some work, and something that's moving with a mass, you can imagine when it hits something, like a bullet for example, has mass and it's moving at a very high velocity, has a lot of energy. When it hits something, that something's going to experience a force and have the ability to move backward, when they get hit from the recoil through a distance. So kinetic energy implies that the object that's moving, that has this energy, has the ability to do some work. But kinetic energy, or energy of motion, so this has to do with motion, is not the only kind of energy we can talk about. We're going to talk about potential energy. And potential energy sometimes is thought about as stored up energy. It's when an object has energy just waiting to get unleashed and do some work. So for potential energy, the stored energy, there's two varieties that we're going to talk about here today. One is gravitational, that has to do with the force of gravity, and the other is something called elastic. So let's look at gravity first and see what we're talking about. Let's say this is the Earth, so this is the ground, and I have an object here. Let's say my object's 10 kilograms, and I'm going to take the object and I'm going to raise it. I'm going to apply a force, and I'm going to apply a constant force on this object, and I'm going to lift this object up 10 meters high. So I'm going to apply a force here, constant force. Object's going to move at a constant velocity upward to a height of 10 meters. So here's my 10 kilogram object now. So I raised it up a total height of 10 meters. Now I did some work on the object, didn't I? And if we know the object's weight, which we can always calculate, the weight of any object is always mass times the acceleration due to gravity. In this case, we know this number already. It's 98 newtons because mass is 10 and little g is 9.8. So 10 times 9.8 is 98 newtons. So that's the weight. And if we're going to lift it at a constant velocity with a constant force, you know the force that we're going to be picking it up at is exactly 98 newtons. Then we will have a balanced system, and I'll be moving at v constant. Okay? So constant velocity means no acceleration. So the force that I'm lifting is exactly equal to gravity. Now you might say, well, how then does the thing move if we're balanced? I guess it's standing still. And that's true. Something standing still will have a weight downward and a force upward from the floor. But what I'm going to do is when I apply the force, I start to take away the force necessary from the floor to balance the system. And when I reach the 98 newtons that the weight is at that point, I can easily make this thing move at a constant velocity. So anyway, we're up here 10 meters high. Now would you say that this crate here that's 10 kilograms possesses the ability to do some work? It does, because gravity is acting on it, and gravity is a force downward. So the force of gravity now can do some work on this box in moving it downward. So the force of gravity can move it down 10 meters. And the work done by, let's say, gravity here in moving from this new position to the final position back on the ground is equal to the force of gravity times the displacement which gravity is going to go. So this force of gravity, we know how to calculate it. That's the weight. That's mass times the acceleration due to gravity. And this displacement here, we'll just continue to call it d for displacement. This is the displacement right there. So that's the work done by gravity, mg times the height. let's figure this out. This is going to be 98, and the height or the displacement is going to be 10. So that's going to be 980 joules. All right, now always remember work is units of joules. So we say that by virtue of raising and picking this block up off the floor a certain height, we give it some potential energy. Potential energy which can then later be converted into work done by gravity. So I'm going to make a definition here. Potential energy for gravity is simply the mass of the object times the acceleration due to gravity, that's the force of gravity, times the height. Times the height of the object, that's the displacement, that's going to be the height. So potential energy, we remember this formula, is m times g times h for the height. So anytime you raise an object up off the floor a certain height h, you've given the object some potential energy equal to the mass of the object times the acceleration due to gravity times that height that you raised it off the floor. Now it's got energy in weighting. Now actually what's going on here is when you are lifting the box upward with some force, you are doing work against gravity and storing that energy into the box, and gravity later will then do positive work on the box as it falls to the ground. Now let's go over here and talk about elastic potential energy. Elastic potential energy is something we consider when we talk about springs. Suppose I have a spring here attached to a wall. And this is the relaxed length of the spring. So this is relaxed. And then I come, so here's the wall, come along and I take this spring and I stretch it out to here. I pull it out to here, this far. Well, if this was the relaxed length here, that's the relaxed length. Did I spell that wrong? GTH. Then this part here is what's stretched. Okay? So by virtue of stretching the spring, I put some energy into the spring. I applied a force, F, to pull the string out. I applied that force through a distance or displacement vector, D. So I did some work on the spring. Work was done on the spring. Work done on the spring. In this case, when we're talking about work done on the spring, there's a special formula for it, all right? And that formula has to do with the potential energy, elastic potential energy of the spring is 1/2 K, constant K, times X squared, where K is a constant that's unique to the spring you're talking about, and I believe K is going to be in units of newtons per meter, because X is going to be in units of meters, so you're going to have meters squared. So when you cancel this out, you're going to be Newton meter, which is the joule. Remember, 1 joule is 1 Newton meter. So anyway, the units of K is this Newton per meter unit, and that's a given. That's just a constant number that we plug into this formula. X now is the stretched length. Okay, so for example, if we have a spring and I say K for the spring is, let's say, 5, and I stretch the spring, let's say I stretch the spring 1 meter, because I want to make this easy. So X, the length that I'm going to stretch is 1 meter. So how much work is stored now as potential energy in that spring? Well, the potential energy elastic is 1/2 kx squared, which is 1/2 the k, which we said was 5, and 1 meter squared, so that's going to be 2.5 joules. All right, so I'm going to do an example in a problem or two for you in another video.